Chapter 7, page 3. Now on the previous page, we started doing the E and the Z configurations for simple cis and trans. Let's go ahead and keep looking at this. So, just like we said in the previous one, if we take a look at the first carbon of a double bond, or one of the carbons, we pick the highest priority group on it. Take a look at the other carbon, pick the highest priority group on it. And then we say if they are on opposite sides, it's the German word entgegen, so we say that's the E configuration. If they are on the same side of the double bond, then we use the Z for zusammen, meaning together or the same. Well, why do we have this? Why don't we just do simple cis or trans? Because of examples like this. Are you going to say that the methyls are trans or the it gets a little complicated. And then when we get into the next example right here, you can notice that it's really, you got all sorts of different groups. So this is where the E and the Z really come in. For simple molecules, like the example that I did above, cis and trans is good enough. But for more complicated ones, you have to pretty much go to E or Z. And all we're doing is we're using the priority groups just like we did back in the stereochemistry chapter. So let's go ahead. Tell me on this one, what's the configuration? So I'm going to do the same thing that I did earlier. I'll highlight out the two carbons, and then I'll pick out the priority groups on each one. So on the green carbon right here, what's the highest priority group? Well, a carbon is the same as another carbon for the ethyl, but this bottom carbon only has 3 hydrogens. The carbon up here has another carbon on it because it's an ethyl group, so it would be the highest priority group. And then this methyl group is the highest priority group, higher than a hydrogen. So on the green carbon, the ethyl is the higher priority group. On the blue carbon, the methyl is. They are on the same side, so we say the Z for together or the same. Let's do the same thing over here. I'm going to highlight out the two carbons of this double bond. On the green one, the higher priority group is going to be this ethyl, and on the blue one, the higher priority group is the bromine. Now if I take a look at this, they're on opposite sides of that double bond. So if they're on opposite sides, we're going to give this the E configuration. On the last problem right here, what we do, again, take a look at the two carbons of the double bond. On the green carbon right here, the chlorine is going to be the higher priority group over the carbon of the ethyl. On the blue carbon over here, this part of the chain is going to have a carbon, then it has oxygens attached to it. The methyl is just a carbon with hydrogens. So again, we're just doing the same priority groups we did for stereochemistry. And since they're on opposite sides, that's the E configuration. So now that we know how to designate things as Z or E, let's go ahead and give a full name for a compound like this. Now, let me remind you of the rules. You pick the longest carbon chain that has the double bond. The longest carbon chain that has the double bond is actually going to be here, not the one in a straight line, so always be careful. And when I'm doing this, also if I'm going to put them in order, the double bond is closer to the left-hand side of this than the right-hand side of this chain. So I'm going to number it from the left-hand side. No matter where the branching is, when you have a double bond, you always number it from the end closest to the double bond. So 1, 2, 3, 4, 5, 6, 7. So now let's go ahead and put in the full name for this thing. It's going to be a 7. Take the heptane name and then drop the ANE and make it a heptene. All right. So the parent is going to be 3 hep HEPT, sorry about that, ENE, or hept 3 ene. Now, I've also got other groups on there, okay? I've got methyl groups on carbons 3 and 5. So I'm going to say 3, 5 di methyl, and then I've got a bromine right here on carbon 4. So I've got a 4 BRO bromo. And again, we're just reminding ourselves of a lot of the nomenclature. Alphabetically, M for methyl, B for bromo, so the bromo is going to come first. Now, since we're naming this thing fully, we also have to figure out, is it the E or the Z? So let's go ahead and do this real quick. And I'm going to erase the stuff that I highlighted right here. And then say, all right, let's go ahead and go back to what we were doing. I'm going to highlight carbon 3 there in the green and carbon 4 in blue. On the green carbon, the highest priority group is this ethyl. On the blue carbon, the highest priority group is the bromine. And so they are on opposite sides, so we would say the E configuration. So where does that go in the naming? It's either going to go in front of the whole name, or it's going to go back with this number right here. And I've seen it both places, so just be prepared to do it in both places. But here we go. Let's go ahead and name this thing, and we'll do it both ways. So, if I'm doing it with the letter in front of the whole thing, I would say E, and you'll many times see that in parentheses for the configuration of the double bond. And when you have a single double bond, that's where it's put a lot of the times. And then I would say 4 bromo, because I list the bromo first, hyphen 3, 5 dimethyl, and then hept 3 ene. So once you find the parts and put them in alphabetical order, if there's a single double bond, many times we just put that letter in front. Sometimes you'll see it right with the double bonds, so you might also see it as 4 bromo, 3, 5 dimethyl, hept 3 ene. And even sometimes you'll see them put this in parentheses, but most of the time it can be written like that. Well, that's how you can fully name molecules with double bonds. Let's do one more example with a diene. Take a moment to think about it, and then continue playing this recording. All right, so if we thought about this thing for a moment, we'll say my longest carbon chain is going to be right here. And I'm going to number it from this end because that's closer to where the double bonds start. Irregardless of where the branching is, when you have a chain with a double bond, you always name the longest carbon chain with the double bond and you number it from the end closest to the double bond. So this is going to be a heptadiene. Hepta, and one of the double bonds starts on carbon 2 here, hepta 2, and I've got to also figure out the configuration of this one right here. So it's going to be a 2, 4 diene, and then the different groups off of here are, I've got a bromine on carbon 4, and I've got a methyl group here on carbon 3. So, with that said, and numbering it alphabetically or doing it alphabetically, the B for bromo, the M for methyl. Now I've got to figure out the E and the Z for the double bonds, and then I'll be all set. So, E and the Z for the double bonds. On carbon 2 right here, that carbon is of course going to be a higher priority group than the hydrogen that I'm not showing. And this bond right here, I'll go ahead and do it like that, going to the carbon 4 that has a bromine is a higher priority group than the methyl on carbon up there on top. So this is going to have an opposite configuration for this double bond. When it's the opposite configuration, double bond number 2, and I'll just sort of put it up here on top, is going to be an E configuration. Over here on the double bond that starts on carbon 4, the bromine is the higher priority group, and then that chain, so that's a Z configuration. So, since it's on the same side, so that's a Z configuration. So let's go ahead and do this whole thing. For bromo, 3, 3-methyl. I'm trying to color code it the way we did it. Hepta, 2E, 4Z, diene. So it's not really super hard. The first part of naming this thing is what we did a long time ago. Of course, you still have to know the name of the first 12 compounds, and then you have to learn how to do the double bonds and do the E or the Z in there. And then if there's a single double bond, it's an ene. If it's 2 double bonds, a diene or a triene or a tetraene. All right. Now, last bit on this. I'm not going to test you on this. One of the biggest use of alkenes is to form polymers. And we'll talk about that in Chapter 8 when we get into the reactions of Chapter 8.